Welcome to Penultimate Touch. So we have already completed 4 parts of triangle counting. Today we are studying the next part. If you have any questions or issues regarding previous classes, then you should comment, okay? Now look at it carefully. Triangle counting, part or type 5. Clear? Okay. Now let's see. We have already done this type. So how many triangles were there in this figure? 3 triangles. 1, 2, and we sum this up. 3. What are they? First triangle, second triangle, and the larger one. 3 triangles. So if a figure comes like this, like now, how many triangles are visible now? 2 triangles, right? If we join the apex here, now how many triangles are there? Are there 4? No, it's 4. It's not 3. Okay, 3 triangles and the larger one. It's the 4th triangles. There are 4 triangles. There are 4 triangles, right? So now, if we add one more straight line to join a side, how many triangles will be created? There will be 8 triangles. How? Suppose it is A, B, C, O, and it's D, right? So in AOC, how many triangles are there? 3 triangles, right? So there's a 4th triangle, there is a 5th triangle, and after 5, you can see that triangle ABD is there, and triangle BDC is there. So now there are 7 triangles, right? And there is a larger one, A, B, C. So there are 8 triangles in total. I hope it's clear to you. So if we add one more straight line here, suppose this is a triangle and it has such joining lines. Now how many triangles will be there? Just use your common sense. If no straight line is joined on the side and it's coming from the every angle, so there are 4 triangles, but if one more line adds, then there are 4 more triangles, right? So if one more line adds this one, so it will add more 4, so it will be 12. And if it will have, sorry, this is not a straight line at all. So if this kind of triangle is there now, and all the divided are touching the sides, then how many triangles will be there? Look, to remember this, you just have to notice that if no lines are touching the sides, then 4 triangles. 1 touch, 8 triangles. 2 touch, 12 triangles. And when 3 lines are touching the sides, it is parting the sides, is dividing the sides into 2 parts, then there will be 16 triangles. It adds 4, then plus 4, 8, then plus 4, 12, then plus 4, 16. Each straight line is creating 4 more triangles. I have shown you that how these 4 triangles are counted. Look at this. In ABC, if this one single line adds, then it creates 1, 2 triangles, right? And next, and more 2's are coming here, A, B, D and B, D, C. So for each joinings there will be 4 extras, right? So 4, 8, 12 and 16. You have to remember this. This question comes straightly in the exams. Like how many triangles are there in this given figure? If this figure number 4 I'm talking about. Okay, I hope it is clear to you. Now moving to the next part. Look, it's type 6. Clear? So in type 6, you have to know, look, how many triangles are there in this figure? I've said that a triangle is the largest part of figure counting. It has several parts. Tell me, how many triangles are there in this given figure? How many can you see? 1, 2, 3, and fourth one, 4, and the larger one ABC. Clear? So plus 1, it's 5. So if I add one more triangle inside it, how many triangles will be there? 4 more triangles will be there. 3, 4. These 4 triangles will be added inside this. So it will be 5 plus 4, 9. Right? If you add one more triangle inside it, right? So how many triangles are there now? 4 more triangles will be there. So you have to remember that if a triangle is made inside a bigger triangle, it creates 4 more triangles, which actually touch every side. So you can say that if a smaller triangle is drawn inside a larger one, touching every side of the larger triangle, the smaller one creates 4 triangles. Clear? How it is clear to you? This is something you have to avoid. Sorry for this. I hope it is clear to you now. If a smaller triangle is drawn inside a larger one, smaller triangle. Suppose ABC is the larger triangle and this is MNO. Okay. Smaller triangle MNO for an example, and larger triangle is ABC. This is a larger one. ABC. Clear? So if a smaller triangle is drawn inside a larger one, touching every side of the larger triangle, the smaller one creates 4 more triangles. I hope it's clear to you. 4 more triangles, 1, 2, 3, 4. If you add one more, like if it's ABC, this is MNO, and this is XYZ, then this XYZ creates 4 more smaller triangles. So we have to add 4 there. It's 4, so there will be 9, and 9 is there, and one more is there. Suppose this is PQR. This PQR is making 4 more triangles, so it will be 13. So this is how you have to calculate this. This figure you can calculate in the exam easily, but when the figure comes like this third figure, it will not be easier to calculate you. It will be confusing. So you have to remember that how many how many triangles are there inside the bigger one. One triangle, two triangle, and the last one, three triangles. So three triangles means 3 into 4, 12, and one bigger one. So it will be 13 the answer. I hope it is clear to you. If you have any queries regarding this question, sorry, not this question, but this concept, then you should comment or ask your queries without any hesitation. So now we are moving to the next type. Look at this carefully. This is type 7, right? Is the most important part of the triangle, or the I think it is something you have to remember very well, that this kind of questions are very common. This question comes straightly. Basically, this is not a type, this is a part of question, you can say. Fine. So if it's ABC is a triangle, how many triangles are there inside this? You can find that according to the previous part, it has 5 triangles in this part, like ABC, DE. But there are 2 more parts, right? So you can't calculate this from this previous type. It will be hard for you, it will be confusing. But there is a formula. There is actually 2 formulas to calculate this. What are they? If there are 3 parts, right, on each side. On each side there are 3 parts. I hope it is visible to you. So if it has 3 parts, this 3 is the nth number, right? And this, if this nth number, if n is equals to, if n is equals to 4 or less, then you can imply 2n square minus 5. Clear? 2n square minus 5. So how many triangles are there inside this? If this n is equals to 3, then it is 3 into 9 minus 5, 18 minus 5, 13. Clear? But if n is equals to 5 or more, then this formula 2n square minus 5 can't be applicable. Why? Can't be applied. Why? Because this formula is limited till 4. If it is n equals to 5, then you have to use n into n plus 2 into 2n plus 1 divided by 8. Right? Sometimes the resultant is in decimal. You have to take the nearest value, nearest whole number. Okay? So if this is applicable for not 5 or more, but 3 or more. 3 is the smaller one. This figure cannot be made without 3 parts. It is actually 3 or more, but can be applicable, but cannot be applicable. This first one cannot be applicable after the 4. It cannot be applicable in 5 or 6 or 7. But this second is applicable in both the parts. This is a smaller one. So if the number is small, like 4 or 3, then this is enough to calculate this. But if the parts are 5, suppose this is the figure you have got at your exam. There's no straight line, but pad on it. So how many parts are there? 5 parts. Here are also 5 parts. So for this question number 2, you have to imply this. Why? Why do we have to apply this? There n is equals to 5, 5 plus 2 is 7, and 5 2s are 10 plus 11 divided by 8. So it's 35, 3, 8, 5 upon 8. 4, 8 point something. You don't have to take the decimal. 48 is the answer. Now, if you want to satisfy if 48 is right or wrong, there is another way. This is the three way to solve. The third way is you just have to write the numbers like this, right? Then you have to add 1, 2 plus 1, 3, 3 plus 3 is 3, 6, 6 plus 4, 10, 10 plus 5, 15. Now have to sum this up. What is this? 3, 4, 6, 10, 10, 10, 20, 20, 30, and 15 is 35. 35, right? And now we have to take the even parts. What are the even? If this is the first one, this is the second one, this is the even. This is the third one, is the fourth one, this is the even. So 10 and 3, 13. So you have to add 13 here. So 48 is the answer. Right? But if you use 2n square minus 5, what would be that? If n is equals to 5, then it's 25 and 20, 50, 50 minus 5, this will be 45. But 45 will not be the right answer. You can't apply 2n square minus 5 when there are 5 or more parts. Okay? If the baseline or any sides are getting divided by 4 or more than 5, 5 or more than 5 parts, then you should apply this formula, or you can go with this. But if that is 15 or 16 parts, then you can't actually calculate this much number perfectly. It will be confusing. It can be a wrong answer. So my suggestion is to use n into n plus 2 into 2n plus 1 divided by 8. This formula. This is a universal formula. You can use it here too. If you use in 4, if n equals to 4, you can apply this in 4 too. How? 4 into 4 plus 2, 6 into 4 to 8, 9 divided by 8. 4 2s are 2 3s are 27 is the answer. Right? So if you use 2n square minus 5 here with 4, so it will be 2 into, how much is it? 4, so 16 minus 5, so that will be 32 minus 5 means 27. So this is the universal formula. This is the universal formula. You can apply it anywhere. So you have to remember this formula very well. N into n plus 2 into 2n plus 1 divided by 8. Or you can apply this part, this 2, but this 2, but I think this is not a beneficial part if the numbers are very calculative. Okay? I hope this concept is clear to you. If you have any doubt regarding this concept, you should ask. Still, I am saying this is the type 7, which is actually a part of the questions. These are the straight questions. If this question 2, this one, can come in the examination straightly. Now, mostly all types are completed. Now we have to solve questions from triangle counting. I am solving it for you. You will solve and I will give you the solutions. After some times, I will give 15 to 30 seconds for every question, and then I will be solved it for you. Now moving to the question answer part for triangle counting. Triangle counting is ending here. Later on we will we'll discuss square, rectangle, circle as well. Okay, and also polygons and straight lines. Now moving to the question answer parts of triangle counting. So look at the first problem. So how many triangles are there in this given figure? How will you do it? I'm giving you 10 seconds to 15 seconds for this. This is a simple one. We have already discussed this type earlier session. It is done. If you haven't done it yet, look at it. How many parts are there? 1, 2, 3 and 4. So we have to sum this up. How much will be it? It's 10. How many baselines are there? 1 first baseline, second baseline and third baseline. So we have to multiply it with 3. So it will be 30. 30 will be the answer. Option A is the right answer. Option 1. I hope it is clear to you. Moving to the next one. Look at it carefully. How many triangles are there in this given figure? 15 minutes. Then I will tell you. So how many triangles are there? Look, there is a figure like this is embedded inside this. It is like that, right? So how do we calculate this? There are 4 parts, 2 diagonals, then it will be 8. And there are 2 parts. So 8 plus 8, 16 will be there. So will that be 18? 14? No. 14 can't be. 18 also will not be the right answer. How many triangles are there? Look, there are extra triangles hidden there. 16 we have counted. It's 17, 18, 19, 20, 21, 22. Is there any extra triangles? No. No hidden triangles, no more hidden triangles. So option 3, 22 will be the right answer. I hope it is clear to you. It's a simple question. Moving to the next one. Now look at it carefully. 15 seconds for this. Do it. So how many triangles are there? So it has a figure like this, right? So how many parts are there? 2, and there are 3 baselines. So 3 into 3, 9. So how many thus this kind of figures are there? This kind of figures are embedded like first one, there is a second one, and this is the third one, right? So 3 similar kind of figures. So 9 into 3, 27. Clear? 27 plus. Is there more? Yes. 27 cannot be the right answer because there are more triangles inside it. Look, if this is A, B, C and D, ABD is a triangle and BCD also is a triangle. So 27 plus 2, 29 is the correct answer. I hope it is clear to you. Option 2, 29 will be the right answer. If you have any doubt regarding this question, you should comment. Moving to the next one. So look at this figure. How many triangles are there? Giving you again 10 seconds to 20. It's not. It won't take 20 seconds. 15 seconds max. So many such triangles are there. So you can see there are how many birds? How 1, 2, 3, 4, 5, 6. 6 birds there. So 12. Right, 12. And from this side there are 3 triangles. 15. Right, 15. Is there any? Yeah, 15. So 16, 16, and this one 17. On the opposite side there is a 1. The 18 will be the right answer. 18, not 20. 18 will be the right answer. Option 3, 18 is the right answer. I hope it is clear to you. Moving to the next one. Look at this. How many triangles are there? Giving you 10 to 15 seconds again. So okay, time's up. How many triangles are there? I have 13 is the right answer. Look at it carefully. there is a figure like this is embedded. Right? So there will be two triangles. Right? Now you will find this kind of figure there. How many triangles are there? 6. But one triangle is there which we have calculated. Right? Like if it is A, B, C and D. Here ABD is this part. And this ABD has already been calculated in this quadrilateral part. So now there are 5 triangles, and before we have calculated 2, so it's now 7, right? Now 8, 9, 10, the bigger one, this one, 11, right? And A, B, suppose this is X and this is Y. So ABX 1 and ADY, ABX triangle and triangle ADY. So 13 is the answer. Option 4, the options were 8, 9, 11 and 13. This 13 is the right answer. I hope it is clear to you. If you have any doubt, you should ask. Moving to the next one. Look at this carefully now. How many triangles are there? 15 seconds for you. Okay, time's up. So many triangles are there. Look, inside this there are 4 parts. So there will be 8. 8, clear? 9, 10, 11, 12, 13, 14, 15 and 16. It's a simple one. 16 triangles are there. I hope it is clear to you. Moving to the next one. Look, we have already discussed this concept. How many parts are there? 4 parts. So which formula is comfortable for you? 2n square minus 5. Or you can use what? N into n plus 2 into 2n plus 1 divided by 8. So first we are using this formula. 2 into 4 square 9 minus 5. So 18 minus 5 is 13. Sorry, it's not, no, it's 16 will be. It will be 16. So 16 is 27. 27 is the right answer. Right? In this case 4 to the 6 and 4 to the 8, 8 plus 1 9. So 8, 4 2 is 8, 2 3 is 6, 9 3 is 27. Right? So 27 will be the right answer. I hope it is clear to you. We have already solved this problem. I made a mistake. It would be 4 square. I had taken 3 square. Okay, that's not issue. That's not any issue. So 16 into 2 minus 5, 27. I hope it is clear. If you have any doubt regarding this question, you should ask. We have already discussed this concept. It is an important one. Moving to the next one. Look, how many triangles are there? I hope 10 seconds is enough for this. I'm just marking this up for you for a better minute calculation. Okay. So how to solve it? You just have to sum this up. 3 2 is a 5 and 3 plus 2 5 plus 1 it's 6. And how many baselines are there? 2 baselines. So 6 into 2 12. 12 is the right answer, right? I hope it is clear to you. Moving to the next one. Look at it carefully. It's a good question. I'm giving you 10 seconds for this. Do it. So how many triangles are there? So it's 18 there and 1, 19. How? 1, 2, 3, 4. 8 from this side, 8 from this side. 1 joining, extra 2. So it will be 18. And this is the 19th one. I hope it is clear to you. If you have any doubt regarding this question, you should ask. So this question is also figure triangle counting. Give you 15 seconds for this. 15 seconds is enough for this. So do it. So I hope you have already counted this. Let's see how many triangles are there. What's your answer? How many triangles are there? Several figures are embedded inside this. Look, first of all, okay, let me change the ink. First of all, this is a figure you can find, right? It is divided into two parts. So two triangles are there. Two triangles are there, right? Next, it is divided into more parts. Where is it? It is divided like this. So how many parts are there? 2, 3, 4, 5 and 6. So 2 to 6 parts now. Next you can see in this figure how many triangles will be there? It has 1, 2, 3, 4, 5 and in altogether it's 6. So 12 parts, 6 into 2, 12. 6 into 2, 12 parts are there now. 12. Clear? Now this 12 and this is not actually 12, it's actually 12 plus 6. It will be 12 plus 6, 18. Clear? 18, this is 19, this is 20. This is 19, this is 20. 20 you have got already. I'm counting it here. 20 you have got. Now 23, this portion A, B, C. This triangle, this is 3. So it will be 23 here. Next you will get 26 from this side, 26. 3 here, 3 here too. So 29. 3 here again. So it will be 32, right? And one more is there, 33. So 33 triangles. Then you will see that A, O, B, this hasn't ever been counted. So 34 is the right answer. I hope it is clear to you. Look, from the first part you will get 6. Then inside this there are 12. So 6 plus 12, 18. 18 you got. Then from each small triangles there are 3 inside that triangles. Inside those triangles. So there are 29, 32 there. 33rd is here, the smaller one. And this AOB is the 34th triangle. I hope it is clear too. It is a good question. It was asked in 2019. Right? So if you have any doubt regarding this question, you should comment. Moving to the next one. Look, okay, the question means the diagram is not that clear. The options are there like 10, number 2 is 13, number 3 it's 15 and number 4 is 16. The options are not clear. So you can see that It is based on the concept which we have discussed today. Solve it. I'm giving you 10 to 15 seconds. Time's up. So what we have learned, when there is a smaller triangle inside a larger triangle and the angles are touching the sides of the triangle, then each triangle creates small four triangles, right? So how many small triangles are there? 1, 2, so 4 plus 4, 8, one larger one, so 9, 10, 11, 12, 13, 14, 15. No more triangles. 15 is the right answer. Option 3, 15 is the right answer. I hope it is clear to you. If you have doubt regarding any question which we have discussed or any concept which we have discussed, you should comment. Thank you. We are signing off for today. In the next day, we will discuss concepts on rectangle and squares and solve questions regarding the topics, means the concepts. Okay. So signing off today. So if you want to know about the triangles more, you should follow the channel, and for squares and rectangles next class will be taken. Okay. Thank you.